Hi friends, I am Vinod Shankaran. Welcome all of you to a new episode. Today we are going to discuss Anova and test of equal variance. Anova or analysis of variance tests the relationship between a categorical variable by testing the differences between two or more means. So here we are comparing the means of two or more categorical variables and test whether it is significantly different from each other, or at least one of the means is different from all other means. The name analysis of variance is based on approach in which the procedure uses variances to determine whether means are different. So here, even though we are checking the means only, but it is using a procedure which uses variances to determine whether means are different. So even though the means are getting compared, it is using variance to determine whether means are different. So the procedure works by comparing variances between group means versus variance within groups. So it's actually comparing the variance between group versus the variance within groups as a way of determining whether groups are all part of one large population or separate population with different characteristics. So here that it is called a typically analysis of variance table or Anova table. So here between means variances, variance between group means and variance within group means are getting calculated, and this ratio is calculated by doing this test is called F test, and its significance is determined by p value. Now Anova has got certain assumptions, which is that the first one is that each sample drawn from a normal population. So this is the first assumption, that it follows a normal distribution. The second assumption is that this population has the same variance. So it has got each group has got its own equal variances. The samples are randomly drawn and independent. It is independent. So the third assumption is that the samples should be drawn at random. In this video, we are going to discuss the importance of test of equal variance, or in other words, what would happen if you do not do test of equal variance before conducting Anova study. And we are going to discuss with an illustration or example. So here we are going to focus that if you don't do this particular assumption, what will happen? What would be the end result of the Anova study? That we are going to discuss in detail with an illustration. Now one example we are going to take up. Following table gives the yields of 30 samples plots under 3 varieties of seeds. So there are 3 varieties of seed, A, B, C, and its outcomes. Yields are given here. The average value of each kind of or each category of seeds are given here. Here it is 20, 20, and the category C is 23. So we want to test whether this is significantly different from these two averages, or these two varieties of seeds mean, that we want to test, and its standard deviation is given here. So we have to find out if the average yields of land under different varieties of seeds show significant difference. So this is what we want to test. So as I said earlier, we have to test the variance, test of equal variance first, then we have to do the Anova study. So we are going to see that how it is getting done. So all the 3 varieties of seeds are given here. It is given in this table. We have to go to stat, Anova, and test of equal variance. Here we have to go to response data that are in a separate column for each. So we have put it in separate column. So we have to select this one. Okay, and we have to select A, B, and C. All the 3 we selected, all the 3 categories we selected, and say OK. So we will see that results here. This is the results. We are seeing that Levin test. This is what we need to check. So this is the p-value is above 0.05. We are getting 58%. That means above 0.05, which shows that the variances are equal, or this is the variances are more or less equal. So it is meeting the assumption that the test of equal variance are equal between three groups. Hence, we fail to reject the null hypothesis. Now we will do the since it is qualifying the test of equal variance test, we can do Anova study. So we will see that how we are doing the Anova. We have to go to stat, Anova, and one way Anova we have to go for, and again we have to select response that are in separate column for each factor level. So here again our data is in separate columns. So we have to select this one, and we have to enter A, B, and C, and say OK. Now we will see it in our presentation. Now, if you see the analysis of variance table or Anova table, we can see that the p-value in this case it is 0.027, right? So it shows that the p-value below 0.5 means it shows that all means are not equal. At least one mean is different from the other two. So we can see that this 23 is different from the other two means, and it is significantly different. How we came to know it is significantly different? Because our p-value is below 0.5. So this is another study for this particular table or this particular data. Now we will see that how we can do it for if the standard deviation is different. Now if you see here, the same table I have given here, and its averages value is given. But here, what I have done is that the average remains same, 20, and in this case, also it is 20, 20, 20, 23, 23. But the standard deviation, it is different. Here, the standard deviation was 2.26, but here 1.4142. Here 3.0551, and here it is 3.7417. Here it was 2.7080, and here it is 3.8873. So the standard deviation in this case are different. Even though the means remain same, the standard deviation is different. Now in this case, we will see that what will be the end result. Now if you see here, if you do the same test of equal variance what we have done in the earlier case, if you see the p-value is below 0.05, that means at least one of the variance is different from the other two. That means it is not qualifying actually the assumption criteria of Anova study. So we'll see that with this case, if you do an Anova study, what will be the result? In this case, the mean remains same, 20, 20, and 23. Still, the p-value is above 0.05. That means if the p-value is above 0.05 means we have to retain our null hypothesis. Even though the mean values are different, still it is showing that it is not significantly different from each other, or all the mean values are equal. So in this case, even though the mean remains same like the previous case, since the standard deviation or the variance is different, or variances are different from each other, that is why we got a result saying that these means are not significantly different from each other. Now to summarize the total study, you can say that In this case, the test of equivariance was which was equal, more or less equal. In this case, the Anova studies said that, or we have seen that the mean value is significantly different from these two categories of seeds. But when the test of equivariance are different, when it is not, the variances are not equal, even though the mean value remains same, it is showing that, or it is saying that the means are not significantly different from each other. So for the same set of means, if the standard deviation or variance varies, the results are just opposite. Hence, the test of equivariance is mandatory. So we have to essentially do test of equivariance before doing any Anova study. So that is the outcome of this particular exercise. So thank you all for watching this video. If you have got any doubt, please feel free to ask. Send a mail to vinod.s2014-0504@gmail.com, or you can send a message to 9043041339. Thank you all once again.